right. Welcome everybody to the December 13th, 2022 Global User Group meeting for Cribl. We do have some news and stuff to mention first before we get into our main feature, which is we are changing the time of this meeting. We are shifting it up so that it's better mostly for our European neighbors. It comes in kind of late at night for them right now. So we've moved everything up by, is it 4 hours? 3 hours.
Yep, 3 hours.
To 10 a.m. Pacific time, which is, I will just look at my cheat sheet because otherwise I'm going to mess it up. And XPAC's not on right now to yell at me for getting the GMT times wrong, right? UTC. Yeah, 1 p.m. Eastern or 6 p.m. UTC. So that should put it, at least not very late in the evening for most of you folks over on the other side of the Atlantic. So hopefully that'll help draw a few extra people there. So that will start next meeting, which will be the second Tuesday of January. And I think we're good with all that particular set of meetings. Let's see here. So I guess 1, 2, 3. Yep, we have people, and I haven't seen anybody new in a few moments. So it's time to learn about Cribl Search. Would you like to take it away? You can give yourself a brief introduction.
Let's do it. Thank you, Rich. Appreciate it. So Dritan here from the San Francisco office, one of the co-founders at Cribl, currently running a product for our search offering. Obviously been here at Cribl since the beginning. It's been an amazing trip with Clint and Legion. Clint, obviously you guys have heard from in the past. Super excited about this opportunity. Our community means a lot. And Rich and Tony, thank you for setting this up. I'll go on record and say that, hey, if you ever want me to come back, I'm just one Slack message away. So if you ever want to hear about new features or new things that we're developing, more than happy to show up here. And I can't wait until we all get in person at least once a year. I hope that we end up with some sort of CriblCon of sorts, but this is great. This is fantastic. So Rich, in terms of the format and logistics, I have prepared a couple of slides just to sort of get us into the context and the background for search. It's like 4 or 5 of them, and I'll just go through the demo, and then we'll just sort of open it up for questions and discussions.
Yeah, we really like demos, but yes,
Yep.
A few slides are often good too, though, because sometimes that lays out what we're going to do. Right, absolutely. You might be able to just click share.
Yeah, I'll try that in a moment.
Tend not to tie these Zooms down real tight.
Yep. So I'll do that. So let me know.
Take it away.
Let me know if you see the screen here.
Yep, sure do.
Fantastic. So just a couple of slides just to set the context. What is it that we're trying to solve with search, and what's the motivation behind it? And more specifically, what's the motivation to the approach that we're actually following with search? So as you know, I mean, you obviously are using Cribl now for some time. When we set our vision for the company a few years back, we wanted to provide or build a platform to provide observability data, or rather visibility into all the machine data that all the endpoints, all the services that you have emit. And to do that, we started with Stream. Stream is something that obviously you've got a lot of experience on. Then earlier this year, we released our Edge product. Edge collects and then processes and forwards data out to all sorts of destinations, pretty much everything that Stream supports, but it's mostly built to work better with Stream rather than other destinations. And then earlier this year, so namely about, let's see, 5 weeks ago, we released Cribl Search. Cribl Search is attempting to solve 2 big problems that we have observed up until today from our customer base and from our market in general. One is what we call the big data problem. At the heart of this problem is really the difference between the data growth curve and the IT budget growth curve. So data is growing at an exponential rate, rather 27% year over year. When you talk to customers, their IT budgets are only growing at 7% year over year. And so they need to figure out a way how to manage all these data. And today, they are required to actually collect the data for audit and compliance reasons and all the like, sort of other use cases that resemble those, and then just sort of take it, probably store it or archive it somewhere because the RT budgets are not keeping up with the rate of growth of the data. So the infrastructure cost is not proportional to the data growth. The other problem, which I found really interesting, is that what I'm sort of referring here to is the data everywhere problem. Whenever we talk to customers, they have data literally, in all their sprawling environments. Like there's data in data lakes, there's data in NFS storage, there's data in data warehouses, obviously, log analytics tools, time series databases, and sort of pretty much everywhere. In fact, in talking to most of them, over half of the organizations have about 6 or more monitoring tools. And so we sat down a couple of years ago and we said, hey, wouldn't it be great if we had a solution for these two problems? And we came up with Cribl Search. And at the foundation of it is this requirement, or will relax the requirement that a lot of the outdated tools today have, which require you to collect the data, store it, and then search it. So instead, we came up with the architecture that allows you to query data in place. The problem that we're trying to solve here is that as you generate more data, now you are required to transport more data. You are required to now store more data. So effectively increasing the cost. Meanwhile, your budgets are not increasing. And so what we've done with Cribl Search is built the technology and built the foundation of the technology, rather, I would say today, that allows you to query data at rest wherever it is. In addition to that, problem number 2, we're trying to build a search experience with an ergonomic query language that allows you to query multiple data stores in multiple data formats. So today, I'll show how to query data that rests on Edge and how to query data that rests on S3. And then we have a full backlog of all the other technologies that will be supporting things like SQL backends or NFS stores and maybe even log analytics tools in the future. After you query the data, obviously, you need to do something with it to extract value. Most of you are familiar with how Elastic, Splunk, and all similar tooling sort of works. We're also building technology to create and compose dashboards out of panels. And then the dashboards will allow customers then to just collaborate or even tell stories with data. And then underpinning all of this is an architecture that is cost effective at scale. So when we query data at the edge, that means that now the system that we've built scales with your endpoint footprint. So the more of those you have, the more scalable the system becomes. And then in the cloud, if data resides in the cloud, we've built an ephemeral compute architecture that it will run the searches, and then when the searches finish, it will tear down all the infrastructure, therefore enabling you to realize a lot of those cost savings, as opposed to some of the architectures that you have today, where you have this big, sort of solid systems that just remain up and running. And then the last slide, this is why we're different in our approach, and then I'll jump right into the demo. So if you sort of look back about 20, 30 years or so, the first sort of generation of tooling that enabled customers to query machine data, so logs and metrics and the like, were basically schema on write systems, databases where the tools of the data point. And the way you query data with databases, it typically goes through an ETL process. You do a lot of extraction, transforming, and then you load the data into the database. L literally means you're moving data into the database. The structures that allow you to do this tend to be very rigid. The infrastructure is very stateful. You'll have to stand up, obviously, database servers, and if you wanted to scale them out, you have to bring in more database servers and rack them and stack them. And that's how Larry Ellison became become so fucking rich and has a whole bunch of islands out there. The second generation of tooling, think like early 2000, mid 2000, pioneered by Splunk and Elastic and Sumo and all these sort of I guess cohort of log analytics tools. They lack the requirement for ETL. So all you needed to do is some basic ETLing, like provide like where the line breaks are, and then you ingest the data, but you still had to move it. So you didn't have to do typing or extractions ahead of time or anything like that, but you still had to move it. The systems were scalable. The infrastructure tended to be also pretty stateful, so you had to stand up clusters. Obviously, they were much more flexible, obviously, than the databases, but nonetheless, it was stateful infrastructure. With search, we're saying no ETLing whatsoever, no data movement is required. All of the infrastructure is stateless, which means that the entire sort of system is set up to be super scalable. It scales with the scale of the cloud, or it scales with the scale of your endpoints. So one thing to note here is that we're not requiring the data to be moved. We're not requiring ETLing, but if you would like to move the data, so if you'd like to move it from your endpoints to S3, for example, and you query it there, you can still do that. As offering the choice is what makes our system sort of different from others. With that, I'll end here. I know the whole team here is very technical, so I'll jump right into the demo unless there is any questions or like comments, feedback. Yes, no. Cool. I'll go right into the demo. Let me move these Zoom things out of the way. Cribl Search is available today on Cribl Cloud. It's a cloud-only service. When you sign up for a Cribl Cloud account, you get Cribl Search automatically. You don't have to buy it. You don't have to enable it. It just shows up there. It's free with some limitations, obviously, mostly around the horsepower of things that you can actually do with it. But in terms of features, is fully featured compared to enterprise. The way it works in Cribl Cloud is that it just consumes. So if you have an enterprise plan with us, it just consumes credits from whatever you've purchased, similar to what you do with Confluent and Google and Amazon Cloud. When you navigate to search, so basically you come in here, you click on Cribl Search. Let me just bring this here. So you'll land on this landing page. So I'll just start with sort of backwards here, but there's this section called available datasets. In Cribl Search, we have this notion of a dataset. A dataset is simply a collection of events that can be addressed with a simple key value pair. So for those of you who have Sumo, Elastic, or Splunk backgrounds, think of indexes of data. So you can say things like index equals foo. In those systems here, you can say index equals Cribl internal logs. So you can create as many data sets as you want. And then depending on what the provider of those data sets are, the providers are interfaces, so the external systems, they'll be listed here for you. So for example, I've got I have 4 data sets here listed as or powered by Edge. You can look at the icon on the left, and I have this Cribl Search example. This is a data set that is given to us or provided to us by an S3 provider. On the right-hand side, there's another section that contains sample searches. If the system is new, we're going to default in this particular tab here. If you're running searches, you're going to get the history. I think we track about the last 100 searches over here. So if you want to reference them quickly and easily, you can do that from here. At the top of these two, there is the query box. This is where you interact with the system. This is where you enter the queries. There's a couple of settings here. We ship with our documentation out of the box. So if you click on this guy, there's a bunch of operators that we ship with. I think I'm running on an older build here. We have about 15 operators, maybe 16 operators that we support out of the box. And then about, I don't know, like a couple of hundred functions here. At the top right, you have a time picker. This scopes the search to the time that you select over there. To the left of it, there is a sampler by default. It defaults to no sampling, so it's full fidelity. But if you're just interested in looking at or answering questions like, hey man, do I have data into the data set? Just for presence of data, you can just pick one of the sampling options here, or you can enter a custom option, and you can answer the question quickly. And then at the top here, you get the saved searches. So if you find yourself running searches, quite often, you can just save the strings, and then history here, it shows the full fidelity of history. Let's go ahead and run a search. I'm just going to pick on this one, pick the first one. This language may look pretty familiar to you. It's a pipe delimited query language. It is based on Kusto. It is actually Kusto. Kusto is used a lot by Microsoft Azure cloud products. So Azure Data Explorer uses it, Sentinel uses it, a couple of other products as well. It's very flexible. It's an open source implementation. We sort of did some research early on, and we decided to whether we built our own or use something that has been getting some traction. And it looks like Kusto has quite a following, and it's very intuitive. It's pipe delimited, based on the Unix pipe model. So you start with a definition on the left, and then you pipe the output of that particular query through operators, which slice and dice the data in every which way. We're not trying to reinvent anything new here. This is exactly what Splunk uses, Kibana, Sumo, literally all the log analytics tools use some sort of pipe delimited language. When you run this query, you get a little timeline. Again, not trying to reinvent the wheel here. We're trying to give users and our operators sort of like the same sort of look and feel that they get with other tools, at least for now, and then start to differentiate later. So in this case, what I'm saying is hey, go into my internal data set and then just return 100 events, put them on a timeline like this, give me the actual events that you returned, and then extract some fields on the left. Again, the UI may look familiar to that of Kibanas and Splunks and the like. But here you can also keep adding things. Like we have this operator called extend, and extend does what it's supposed to be doing. So it adds a field called foo, and then assigns a value of bar, and then it just sort of decorates each event with that field. And you can do operations here. So like foo, or rather I can say bars equals 42, and then I don't know, bars times 4. You can do operations like that. As you noted, or as you saw, every time you type, you get a type ahead assist, type aheads. So let's do an extract. So as you hover over them, or as you try to put focus on them, you get all the documentation sort of built in with examples. We try to make it as user friendly as possible here. So just run a couple of other searches to get us going. I have some saved strings here. Here's another one where I can do things like this. So basically I'm saying data set equals internal logs, only return the fields that, or only return the events from that source ending with cribl.log, where the CID field is set to API, and message that, and then build me or render me a time series of the average of the CPU perk. CPU perk happens to be a field in those events. And it will do this assuming it finds the event and builds a little nice chart for you here. You can come in and you can just change, I don't know, if you don't like bar charts, you can do line charts, or you can do area charts. Now, I'll pause here before I address any questions, but one thing to note is that this data is just sitting on the search service file system, and we haven't indexed it, we haven't seen it before, we haven't done anything with it. We're just going in and querying it directly from disk, and then doing literally all the extractions, all the time stamping, all the time series computations, and then rendering here at runtime. So I'll pause here before I run another search and see if there's any questions, or before I go over to S3 rather. So Any questions from the audience?
I did have one. The performance scales out very well, but that's really just dependent then on wherever the data is being saved, right? It scales as well as the source material scales outwards and to bigger time ranges or whatever.
Correct. Yeah. So Rich, so if you were, so this is just searching internal, and I'll show an example with Edge and S3. You're right. The throughput will scale linearly with the size of your infrastructure. So if you have 100 edge nodes, all of those will run 1/100th of the search, if you will, and they'll just return everything to the service here. If data resides on S3, we're going to spin up enough ephemeral resources as objects as we find. Right now, there are some limitations, and I'll show exactly how that happens. But you're right. When data is in cloud, we're trying to leverage the fact that in cloud you have access to almost infinite resources in terms of compute.
Right.
You bring them up as the search is running, and then you just tear them down immediately. There is a little latency penalty. Obviously, remember, we've never seen this data. We've never indexed the data. So we're not, so if you're doing like needle and haystack kind of searches, that's not the use cases that we're going after, but at least for now. But the throughput is incredible. So once that ephemeral compute is up and running, you get a ton of throughput almost instantly. So there's a couple of questions here in chat.
Perfect. I'm glad you saw them.
Hey, it's Josh here. Can I jump in with a couple questions?
Yeah, for sure.
So, to follow on actually there, because something just made me think of something else with Rich asking this question. So if you do have latency issues with a couple nodes and you have results returned late, do they automatically then, like the search results adjust on the fly for those late return results, or how does that impact the overall, or are they just dismissed because they were too late coming in?
Josh, it's a combination of both. Obviously, there are timeouts, so and I don't think we expose those here. But if those nodes, so if you're running a search against Edge, for example, if those nodes fail to respond within a certain period of time, and it's in seconds, right? So it's not milliseconds. Because of whatever reason, the node went down, or there's network segmentation, or whatever the case, we will produce the results, and then we'll give you a little right up here, little warning where I'm waving at the screen here, saying, hey, you may be getting partial results because of whatever reason. For the most part, we have yet to see that. Obviously, it's the early days, but to answer your question, yes, we are accounting for that.
Okay. And second part of that, question, that kind of maybe is the same answer almost now hearing that. Again, I know it's still early days, but thinking here like a time series type of chart, right? If you have nodes that have differing retention periods, how, like, is it reflected anywhere that says I've got, 7 results from one, for one time period and 3 results for the other, therefore there might be a skew in the average calculation that I'm doing here?
That is a very good question. So I don't think we account for that. We're just sort of bringing in all the events that the edge nodes in this, assuming we're doing edge search, that the edge nodes respond with. I don't think we're doing or rather accounting for that retention policy, simply because, first of all, we don't even have a notion of retention policy for the edge nodes yet.
Right.
So we're just taking whatever they give us as fact, but that's something that we should probably think about.
I'm just thinking of like this use case example, where you're doing averages, or when you start to break into like standard deviations and stuff, right? Like that's going to impact the ultimate calculations, right? If the underlying nodes differ. Okay, I'll go back on mute. Thank you.
Yeah, no problems. Good questions.
Yep.
Anybody else?
Carlos had a question about, is it possible to execute sub-searches like joins, appends, like SPL can, and does Custo support that? Or do you?
Custo does, but we don't yet. I would also add here that we are extending Custo to a point where we think it's appropriate. So, for example, this everything before this first pipe here is what we're calling the Cribl operator. Custo has a search operator. It also has the ability to do the joins, but we have yet to implement them. So the search operator, the syntax is is fairly gnarly. So we decided to take on and then build our own, or extend Kusto to build our own
Okay.
Cribl operator. So we will eventually support sub searches and joins and appends, or like whatever we're going to call. I don't think we're going to call it an append, but I totally get you. I understand what you mean. Let me paste in another search real quick here. Here's another example where we're doing some sort of it's almost the same search, but I'm passing some parameters here to time stats. So by default, we will auto span based on the time picker here. Right now, I'm just doing span 5 minutes, and then I'm rounding. So one cool thing to note here is that in Kusto you can do assignments in line. So compared to some other language, for example, I think in Splunk you'd have to do like I think as or something like that. This is something that I really like here, because you can compose a particular search and then you can just sort of rename that field sort of in line. You can just do assignment right there. Cool. Let me switch gears now. I have an S3 bucket set up here. Let me just do some searches there. So when you land in Cribl Search the first time, you will see a wizard that will walk you through to set up either a data set that is provided by Amazon S3 or one that is provided by Edge. So to do it, I'm just going to go through the steps real quick, because I had to preset it for us here. So if you have data on S3, you set up the data set name here. So let me say my data set, and you provide the bucket, my bucket, if I can type. You provide the region, wherever the bucket is. You can do some path filtering here. So you can say, hey, the path includes or doesn't include, or segments include, and so they can be very sort of surgical if you want. And then next, it's going to ask you to provide the authentication method selection for that bucket. So two options. One is keys. We don't recommend using keys, but we have it here for testing and QA purposes. So basically, you give us keys that will authenticate with the account where the bucket actually is, or more securely, you set up a role on that account, and then we assume that role, and then that role. So we built a trust policy between Cribl Search service and the account, and then that role now has a permission policy on a bucket that all we're doing is just getting the object and then listing the objects. So once you're done, you do a quick test, you get a notification that says, hey, it succeeded or not, and then you save it in search. I'm not going to do that because I already have it set up. But let me just go ahead and say data set Cribl Search, and I have a field called data type. It's called VPC flow logs. And then let's return, I don't know, 10,000 events. So what's happening in the background is we're establishing trust with that foreign account. We're assuming that role, we're spinning up enough compute capacity, and then we're bringing in all those events, in this case, 10,000 events that fit in the last hour. And those are of the data type called VPC flow logs. Now notice we did this without forwarding the data anywhere, without ingesting the data, without indexing it. We just pointed search to where the data is, and then we got results in a way that now we can work with it. I mean, to me, this is extremely powerful. I mean, having worked at Splunk in the past, the first few things that you needed to do really was to forward the data, build a whole bunch of props and transforms, index the data, and then and only then you can query it. Maybe that was the right data, maybe that was not the right data, but without moving the data into Splunk, querying it was simply impossible. So here you can also, for example, knowing I have this data intentionally not parsed to VPC flow logs, because I wanted to show you how easy it is now to just do extractions or field extractions in this case. And I can pass, we have this operator called extract. I can pass the source as underscore row. And then I can say parser equals, let's see, I think we have a VPC. So you can do this in line, and you can search this again. And what's going to happen is we're going to spin up that infrastructure yet one more time, and then do all the extractions. And now you have literally destination address, destination port, and just end start packets and all that sort of work. And here you can do, I don't know, let's do a summarize count. By action. And notice how easy it is. I mean, we enable you to just pick the field as opposed to guessing what the field is. So we're doing some caching about the field names, and here I can run this again, and the same thing will happen. We will run the search again, spin up the infrastructure, and then build the table for you with 2 fields. So basically action and then count. Now notice here count became count underscore because I didn't, I could have just done this, or I don't know, I can do foo equals here. But yeah, so I'll pause here before I move over and show off searching on the edge, see if there's any questions. So let's take a look at the chat. Nope, there's no questions in the chat.
I have another question here, Josh. Again.
Yeah.
So I saw, what is the requirement for the data stored on S3? And maybe I missed that. Is it just raw text? GZIP?
All of them work. GZIP works, raw works.
I'm leading into, is there any support for Parquet?
Parquet is coming up. I know. I swear I knew where we were going. Parquet is
specifically because we have a customer that writes VPC in Parquet 2 S3. And that's like a key use case, right? For sure.
Parquet support is coming up like really shortly.
Okay.
I was just talking to engineers today, and it is high on our priority for our next release, for sure.
Perfect. Thank you.
There may have been a lot of AWS just happening, AWS reInvent happening, and their security data lake. So.
Yep. Yeah, exactly, Tony. So that, and Josh, that is one of the main drivers. So now we know that there is a ton of data that at least we know the shape of, even though with Parquet you have the schema there, you can figure it out. But there's data that we are familiar with that we can provide value out of the box, at least with some saved searches, and just being able to interface with Parquet. And funny thing is that we know we can read Parquet with Stream and we can write Parquet with Stream. So just a matter of taking that that piece of code from Stream and then adopting it for search, and it should be fairly easy to do.
Okay, great, thank you.
Fantastic. Cool. So moving on, I have a fleet here of I think about 8 nodes or so. Let's take a look. Yeah. So on the same Cribl Cloud account, I have 8 nodes where I have Edge installed. If you haven't used Edge, I really recommend that you give it a try. Adding and removing Edge nodes from a fleet is as simple as just running a quick bootstrap script. The cool thing about Edge is that we can, from search, directly target any fleets that you have access to here in the Edge product. So here you can go in. Let me cheat a little bit because I did some saved searches here. So let me just copy this real quick. And the way you set up a data set that it's pointing to Edge. Actually, let me just show that first. Let me just show how we set up a data set. So in the data set, in the data tab, you go to data sets, you say, hey, I would like to create a new one. Say my new Edge data set. And all we got to do is select the providers to say, hey, I would like to use Cribl Edge, and I want to query all my fleets, and then I would like to have it go against opt, I don't know, Cribl log. This is where we store our own internal log for now. So it's a hit save here, and if I hit search, it will run the search. And now what's going to happen here is going to go against the entire fleet, and then query the Edge engine that is running on those endpoints, and then bring back the results from their respective opt Cribl log directory. So in this case, you can see there are 8 nodes returning things here. I mean, isn't this cool? I mean, we didn't forward this data. This data just sits on disk on those Edge nodes, and we just queried it directly. You can take this a step further and say, hey, what if So edge nodes also collect and spool some metrics locally. You know, they don't forward this data, but they just spool it as JSON, and these are called edge metrics. I can run a query and say, hey, show me the load average of 1 minute load average against all the hosts. Again, without moving data, without metricizing it, without doing any of that sort of stuff. This is data that just resides on those nodes, and it is made available by the edge engine to be queried by search. And here you can just change, I don't know, change the area, and boom, you get a load average, a chart of all your edge nodes in the last 1 hour. If you choose to move this data, it's just as simple as taking, you know, going to edge and then just flipping it. Instead of being spooled to disk, you can forward it out to your metric destination. But if you don't care about that, you can just query it from search directly. Here's another search here. Let me just go. I have another data set that is pointing to var log. Let's see if there's any interesting things over there. Oh, oops, there's a lot of journal stuff, or whatever this is. But yeah, you also get to see all the garbage that you have access to. Cool, let me go back. I wanted to show you something really interesting here with my previous search. So if we have data that we know is coming from an edge node and we have access to it, we will decorate the host with a link that allows you to now teleport from the query results of the search to looking at that system live. And what we're doing here is so these edge nodes are talking to the Cribl Cloud service. They're establishing this tunnel, and then we're reusing that tunnel to go back and see what those edge nodes are doing. So edge nodes are spooling data there locally for a few minutes, so you can actually see the CPU utilization, use memory, bytes, packets, and stuff like that. They're running processes, so kind of like a mini top view here. Containers, if they were running anything, in this case, there's no containers running there at all. And then what files are available. So you can actually get to see these files live as they're being written, and sort of tunneling directly from the analytics system to where the data is coming from. I don't think there's any other system that can do this today. So super proud of this. So I'll pause here, and then let's see if there's any questions, and we can just open it up to discussion. Any?
So Hillary has one question asking if it'll be available for on-prem.
We don't have any plans for that at all. Really, we are offering Cribl Cloud. We're offering Cribl Search in Cribl Cloud, but the data that we're querying can literally be anywhere. So these edge nodes, for example, these are on my on one of my AWS accounts. So these edge nodes can actually be in your account or can be on-prem, or as we open up, more functionality to query more providers. Let's say NFS or object store elsewhere on-prem, for example, if they expose an S3 API, that can be on your data center, and you can query it from the cloud. I realize that was a long answer to say no plans for on-prem, but the data can be anywhere. I'll stop sharing so that I can see you guys straight.
Can we,
Tony, how are we doing in time?
Good. We still got 7 minutes left before, for standard speaking time.
Perfect.
The question I had was, can I just do this programmatically, just hit up an API to search and then pull the results back?
Pull the results back? Yes, yeah, it is possible. Even though I'll share something with you. We are actually planning to have search results go to a destination of choice. So for example, the use case here would be, I have some data for let's say an incident that happened 10 years ago. I'm going to go back in between March of 2012 and I don't know, May of 2012, and I want to get all this data now to my analytics tool. But before I do that, I'd like to go and investigate and see if the stuff that I'm looking for is actually there. Run the search from the UI, and then take the exhaust of that search instead of coming into the UI, but take it and then point it to a destination of choice. That'll be a big differentiator, because we're hearing this from a lot of customers. And once we're able to do that, then doing what you just asked with an API is just effectively the same thing.
A question on the roadmap. What do you see as like future sources beyond S3?
Yeah, so we're actually hearing a lot. So customers have data, as I mentioned at the top of the call, Josh, that customers tend to have data literally everywhere. Two that keep coming up is BigQuery and Snowflake. Those will be a little interesting to integrate with, simply because we got to take our query now and then convert it to SQL or whatever dialect of SQL they support. And that'll be phenomenal to actually just, once we build that interface, then literally any SQL backend becomes available for query from here. And then obviously joining data with other sources. So actively looking at Snowflake, BigQuery, doing a lot of investigation over the next couple of weeks. And then all other log analytics tools that make themselves accessible through an API. So like Elastic, Splunk, and others, those will be sort of like round two. And we'll see how it goes from there. Customers might come along and just totally derail our roadmap, if you know what I mean. But like we have some idea as to where we want to draw some lines on, and SQL backend seem to be at the top of the list right now.
Yeah, customers are always throwing wrenches in things.
Yeah.
Plans.
Yep. Question, but back to Tony's API access question.
Yeah.
Can other systems talk to this API and render search results from Cribl Search API?
Yeah, I mean, Nick, yeah, everything that you see, I mean, the quintessential answer there is like everything that you see here on the UI is through an API call. So,
sure. Would that be putting together a pack with some things and then putting it up in the cloud, or can you run such a thing on-prem?
We're working towards standardizing some of the pack architectures, but you can, for example, if you're authenticated with with cloud and your account in cloud, you should be able to, like, from a rudimentary command line, just run the search and then use the results or use its output anywhere else that you want, like sort of pipe them anywhere else that you want. Is that what you were referring to?
Well, yeah, we're building a thing that is dispatching searches against different systems, and I'm curious whether we can put you on the list of things we play with.
Yeah, for sure. We should talk. Yeah,
totally. Cool. Very cool. Thank
you. The leader node has an upper limit on the number of edge nodes that can connect and so on. Is there any other limitation within search that would say like that would be anything less than that, or is it just kind of strapped to the amount that the leader can support?
So we're doing a lot of work on the leader scalability, especially. So we upped our sort of limits or capabilities, I would say, Josh, from 1,000 or a couple of thousand to about 15,000 right now with our 4.0 release. We're doing a lot of work to support even maybe an order of magnitude over that over the next year. For search, we're exploring ideas, and this is why the reason that we want to keep it in cloud, because we want to leverage the compute capacity that we get there to maybe just sort of decouple the coordinator process that runs in the leader on cloud and have it outside, so that way we can scale that too. So we're doing some active work there. So scalability is one of the top priorities for our backend batch of work post-release right now. We've tested it with edge nodes in a couple of thousand sort of scale. It seems to work fine. Obviously, it depends on what kind of searches you're running. But more scalability improvements are really planned out post-release right now. The other thing I would say is that for if data resides on S3, we can spin up literally an infinite amount, I mean, a large amount of ephemeral compute without any problems. So we're not really bottleneck there at all. It's just that the edge nodes. Remember, edge nodes, the amount of processing that they can actually use, it's limited to one CPU at most. And so there's some limitations there. So I'm sort of rambling right now. Did that answer the question?
Yeah, no, that's good. I had a follow on that is you said no to on-prem, which I've heard before, and that's understandable and stuff. But do you ever see an architecture or model in which you're federating searches to leaders on-prem, which are then distributing to edge nodes? Because that's kind of a way of getting around, like multiple leaders, a way of getting around the upper limits of edge nodes that can be,
Possibly, right? Possibly. I mean, we're also experimenting with some other ideas to leverage some of the workers, the stream workers, to do some of this load sharing, if you will. So all ideas on the table. I think a lot of work is planned for scaling post 4.0 as we enter new year. So I'll keep you posted on that for sure.
Awesome. Thank you so much.
Yep. Awesome. What else? Tony, we're about 10-2.
Yep.
Um,
If nobody has any other questions, we can get to the drawings.
Well, cool. Sounds good. I think that concludes our meeting. So also notice everybody, if you're not on the Slack already, you should be there. And we are looking for speakers next time around in early January, second Tuesday. Do note the time changed a little, as we mentioned earlier today, and I'll post that back in the Slack channel and everything. And we'll update the calendar, so you might want to double check your calendars at that point. We could do a couple people talking or one person talking. I mean, if you've only got 10 minutes of stuff, that's totally fine. We can work with what we've got. So anyway, contact me or Tony to let us know if you'd be interested. I can help a little bit with like smoothing over an actual presentation, what words maybe to use. I don't know, give you feedback on it or something. But I'm here to help. So let us know. Otherwise, we'll see you next January. Quickly, the 10th. January 10th.
All right, folks. Well, thank you so much. Appreciate the time.
Absolutely. Thank you
Thanks,
so much.
everybody. Thanks,
Great. Yeah, that was really good too. I really enjoyed it. That was lots of fun. So thanks so much for giving that.
Got it.